Okay, here's a probability experiment you might not have, a probability question you might have never thought about before. Let's take a look at the coin flip. Let's roll it 5 times, or flip it 5 times. I got a heads, I got a tails, I got a tails, I got a tails, and I got a heads. So the sequence that I got out when I rolled it 5 times was a heads, a tails, a tails, a tails, and a heads. Now, let's say that I attended to something that you might have never thought about before, and that is the number of switches that I get in a sequence of coin flips. So here I got the first switch, and there I got the second switch. What do I mean by switch? Well, I mean a location in the sequence where we switch from a run of heads to a run of tails and so on. And so I can see that in 5 flips, I got 2 switches. And the question that we're going to model today using R is, well, what happens in the 100 flip case? In 100 flips, how many switches are typical? So let's go ahead and see if we can write an R script that would answer that question. So I'll go ahead and hide this and get my R script up and running. I'm going to go ahead and put in, open a new script and tile vertically and go ahead and get started. So the first thing I want to talk about is, well, how many times am I going to flip it? So let's go ahead and flip it 100 times to start with, and because that's how many flips we want to do. And then let's create an object we'll call coin. So what would be representative of a coin in R? Well, we've got to think of something that has 2 outcomes that are equally likely. One convenient way to model this is to let it be a vector that consists of the 2 values 0 and 1. We can think of 0 as being heads, 1 as being tails. So now if I want to flip it, say 100 times, then what I'm going to do is just sample the coin vector n flip times, where replace is equal to true. Let's just see if things are working. I'll do flips and then table of flips to get a sense of whether or not this thing is working. So here's my flips. It's a series of 1s and 0s emanating from the sampling of the coin 100 times. And the table shows that I got 45 0s and 55 1s, so I can run it again really quick. 46, 54, 45, 55, 48, 52, 50, 50, oops, 48, 52, 52, 48. So yeah, it does seem like it is flipping a coin. We're getting numbers here that are roughly, around equally likely. So we feel like we have the coin flip 100 sequence coin flip now down. And the harder question now is to sort of figure out how can we count the number of switches. That is, when it changes from a run of tails to a run of heads. In order to do that, let's establish a results vector first. So the results vector, we're going to go ahead and let it be the repetition of 0 n flip times. So that just gives us a place to store all of the switches that we want to count. And then we'll start a for loop, I in 1, 2. And in this case, I'm actually going to do n flips -1, and in order to do that, I need that to be in parentheses. I don't want to go to 100, I actually want to go to 99 in this case, and that'll become apparent in just a second. So at this point, what I'm going to do is I'm going to establish an if-then statement that evaluates the logical argument and carries out a certain command if the logical argument is true, or skips the command if the logical argument is false. So the way that an if-then statement works in R is you start with the statement if, you put the conditional argument that's supposed to be evaluated, true or false, next. And in this case, what I want to do is I want to take a look at what the ith value of flips is, and I want to test whether or not it is equal to or not equal to the next value of flips. So that would be the ith plus 1. So I'm going to test if it's not equal to, and a not equal to in R is attained by doing a exclamation point equal to. So it's evaluating whether flips sub I is not equal to flips in the ith plus 1, the next position in that flips vector. And then you have to start another curly brackets, and within that curly brackets are the statements that you want to evaluate if the conditional argument in the previous line is true. So what do you want to happen? Well, what we really want to happen is we want to know, where the switches occur, and the switches occur precisely where, the ith flip position is different or not equal to the ith plus 1 flip position. So what we'll do is we'll put into the results vector in the ith position, we're going to put a 1 in there if we've got a switch. And we'll end that if then with a curly bracket, and we'll end the for loop with another curly bracket. And then the last thing we probably want to look at is flips and results. Before I run it for a large number, I'm going to actually just do the 10 flip case and go ahead and run it. And so I can see that in the flips vector, what I'm getting is a run of heads, 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 tails, heads, tails, tails. So it looks like I should get a switch right here, and I do get a switch there. I should get a switch right here because 0 is different than 1, and I do get a switch right there. And I should get a switch right here because 1 is different than 0. So it looks like the total number of switches would be the sum of results, or 3. So I could run this again with a sum results argument, and again I get 3. There I get 5 switches. Here I get 4. Here I get 4. Here I get 3. Here I get 3. There I get 4 and 5 and so on. So we can see that the program seems to be running the way it should. It's showing us the flips and counting the switches using the conditional argument. I'll go ahead and bump it up to 100 and run it. And now let's just kind of make sure it's working. These are the flips, so these are the heads and tails. And down here are the number of switches, or the locations where I get a switch. So I can see that I get a large string of ones and then a switch, and indeed you can see it 0, 0, 0, and a switch in that, I guess, 1, 2, 3, 4, 5, 6th position. So indeed in the 6th flip I did get a switch. So it puts a 1 in that position and counts it. And it turns out that the sum of results here, it looks like we're getting 48 switches in this particular trial. I could go ahead and run it again. There I'm getting 56. Run it again, there I'm getting 50. Run it again, there I'm getting 42. And there I'm getting 50 as well. So based on the trials I'm seeing right now, it seems like somewhere in between 42 and 57 switches seems to be pretty typical. We could run this a number of times to get a sense of whether or not we get an average number of flips that are typical for the 100 coin flip. So this particular video is meant to show you the structure of an if-then statement. It's actually nested inside of a for loop that's evaluating a conditional argument here in the middle, and evaluating or carrying out a series of commands if the conditional argument is true, and then it'll skip it if the conditional argument is false. So that is the basic structure of an if-then statement in R, and I hope this video has helped you understand how it works.